Good morning, students. Myself, R.B. Suksare, lecturer as a MTT department. Now, the study about the first unit, sixth semester, first unit, introduction to mechatronics. Here, the first question: define mechatronics. What is meant by mechatronics? The mechatronics, the word is composed of mecha from mechanical and the tronics from electronics. That is combination of mechanical plus electronics. That is mechatronics. The word short mecha plus tronics, that is mechatronics. Next one, define system. What is meant by system? The system is three steps, that is input, process, output. One example is system electrical power, that is supply on the motor, and motor the output process is rotation of shaft, that is the system. The system involves what are termed systems. System can be thought of as a box which has an input and an output, and where we are not concerned with what goes on inside the box, but only the relationship between the output and the input, that is the output and the input process. That is the relation between in system. That is already we have explained. Example, motor may be thought of as a system which has its input electric power and as output the rotation of a shaft, that is the system. Next one, example of measurement system, or give an example of measurement system. Here the measurement also thermometer, that is thermometer, the input is temperature, thermometer process, output is number on a scale. That is, a measurement system can be thought of as a black box which is used for making measurements. It has as its input and the quantity being measured, and its output the value of that quantity. Example, a temperature measurement system. Next one, define control systems. Here the control system, here also input, process, output. The example of control system is heating system, central heating system. Here the input is required temperature and the process of heating, and output is temperature at the set values, that is the value is 25 degree, 30 degree Celsius, 20 degree Celsius. Likewise, that is the control of temperature. Here the control system can be thought of as a black box which is used to control its output to some particular values or particular sequence of values. Example, a domestic central heating control system has an its input the temperature required in the house, and as its output the house at that temperature. If that is you set the required temperature on the thermostat or controller, and the heating furnace adjust itself to pump water through radiators and so produce the required temperature in the house. Next one, explain measurement system. In this figure, the measurement system in mechatronics, the quantity being measured. Which one measured? Sensor, to sense the object, that is sensor, and signal conditioner. Next one, the output display, that is the value of quantity, the measurement system. Here the measurement system can in general be considered to be made up of three elements, that is first one, sensor. A sensor which to the quantity being measured by giving as its output a signal which is related to the quantity. Here the quantity being measured. Second one, signal conditioner. A signal conditioner, it takes the signal from the sensor and manipulates it into a condition which is suitable for either display or, in the case of control system, for the exercise. Third one, a display. A display system where the output from the signal conditioner is displayed. Next one, explain open loop and closed loop control system. Here the open loop control system and the closed loop control system. Here the open is there is no any feedback, but closed loop system is a feedback system are arranged. Here the difference is, here to illustrate further difference between open loop and closed loop system, consider a motor with an open loop. The speed of rotation of the shaft might be determined solely by the initial setting of a knob which affects the voltage applied to the motor. Any changes in the supply voltage, the characteristics of the motor as a result of temperature. Changes or the shaft load will change the shaft speed but not be compensated for there is no feedback loop. With a closed loop system, however, the initial setting of the control knob will be for a particular shaft speed and this will be maintained by feedback by regardless of any changes in supply voltage, motor characteristics or load. In an open loop control system, the output from the system has no effect on the input signal. In a system closed loop control system, the output does have an effect on the input signal, modifying it to maintain an output signal at the required value. The open loop system have the advantage of being relatively simple and consequently low cost, generally good reliability. However, they are often inaccurate since there is no correction for error. Closed loop system have the advantage of being relatively accurate in matching the actual to the required values. Next one, sequential control system. Example of washing machine control. Here the washing machine, the sequential control system. Here the one by one process will start and one by one process will end and the feedback system will be carried out. Here the input, the clock and program. Here the process is control unit and the control unit or process are corrections like pump, valve, heater and motor. And the process are washing machine drum. Everything or process involved in washing machine drum. And the process is carried out and the output is water level controller, water temperature control and drum speed control and door is open or closed, that is the control. That is the sequential control system example of washing machine control. Here there are many situations where control is exercised by items being switched on or off at particular preset times or values in order to control processes and give a step sequence of operations. As an illustration of sequential control, consider the domestic washing machine. A number of operations have to be carried out in the correct sequence. These may involve a pre-wash cycle when the clothes in the drum are given a wash in cold, followed by a main wash cycle. When they are washed in hot water, then a rinse cycle when the clothes are rinsed with cold water, cold waters number times. Here in washing machine, the system that used to for the washing machine controlled was a mechanical system which involved a set of cam operated switches, that is mechanical system mechanical switches. The sequence instructions and the instructions used in a particular washing program and determined by the set of cam shoes, that is the washing machine control system. Next one, make use of sketch and explain microprocessor based control system. Here in this control system, microprocessor based, that is input module and process and then output module to output, that is the power supply and microprocessor services. Here in this diagram, the microprocessor are now rapidly replacing the mechanical COM operated controllers and being used in general to carry out operated controllers. They have the greater advantages that a greater variety of programs becomes feasible. In many simple systems, there might be just an embedded microcontroller. This being a microprocessor with memory all integrated on one chip. Microprocessor based controller which has uses to control events and can be readily reprogrammed for different tasks. In figure shows the control action of a microprocessor logic controller, the inputs being signal from say switches being closed and the program used to determine how the controller should respond to inputs and the output it should then give. That is the microprocessor control system. That is the end of this unit. Thank you one and all.